Hi everyone, welcome to today's video on partial variation. Partial variation is a relationship between two variables where the dependent variable is made up of two parts. A constant number, so an amount that doesn't change, and a constant times the independent variable, so an amount that changes based on the independent variable. And it follows the form y equals mx plus b. So y is the dependent variable, so it's the thing that depends on everything else here. X is the independent variable, so it's the one that you plug in. M is the constant of variation or the slope, so that determines the steepness of the line. And B is the fixed value of y, and is also known as the y-intercept. So that's the constant number that just doesn't change, and you add it to this mx part. So the graph of a partial variation should just be a straight line that does not pass through the origin, and the origin is 0, 0. If it does pass through the origin and it's a straight line, then that's an example of direct variation, and I have a video covering that topic if you'd like to watch. So the graph should be a straight line that does not pass through the origin, and that's because y varies partially because of that mx portion, so that determines the steepness of the line. And it also varies partially because of that b value, so that y-intercept. And that's a value that gets added on regardless. So you can see here, no matter what x is, if it's 0, 2, 4, 6, you always have this base value of 2 added on to whatever else. So let's explain this with an example. So this example is hiring a DJ. Imagine you are hiring a DJ for a party. It costs $100 to book the DJ and an additional $150 per hour the DJ plays. So in this example, our dependent variable is our total cost because that depends partially with how long you hire the DJ for, and it also depends on the fixed cost, so the cost that you have to pay regardless. Our variable cost, or our M, is going to be $150 per hour the DJ plays. Our independent variable, X, is the number of hours the DJ plays for. So that is going to be what we're plugging in because we want to see our total cost if we hire the DJ for 1 hour, 2 hours, 0 hours, etc. And our fixed cost, or our B, is going to be $100 because it costs $100 to book the DJ regardless of how long they play for. If they play for 1 hour, 10 hours, you still have to pay that $100 booking fee. So if we plug all our variables into the equation for a straight line, we get our total cost is equal to $150 times the number of hours plus $100, which is our booking fee. So let's break the equation down. The DJ charges $100 upfront no matter what, even if they don't play at all. So even if our number of hours is 0, you still pay that $100 booking fee. And we can show this with our equation. So our equation is C equals $150 per hour plus $100. So here we set H to 0 to demonstrate him playing for 0 hours. And as you can see, if we make H equal to 0, 0 times 150 just goes straight to 0, and all you have to pay is the booking fee. And this $150 times the number of hours is because for every hour the DJ plays, you pay $150. So this is the rate of change or the slope of the graph. So this is what determines how steep the graph is. And if we were to graph the equation, you would see at 0 hours, you still have to pay that $100 booking fee. And for every hour after that, it increases by $150. Now let's go over some examples. Example 1 says, identify each relation as direct variation or a partial variation. So the equation for a straight line is y equals mx plus b, where m is the slope and b is the y-intercept. In a direct variation, the y-intercept is the origin, so it's at 0. So if we make the y-intercept 0, we just don't have this b portion, so we just get y equals mx, where m is your constant and your slope. For partial variation, we do have this b part, so we do have a y-intercept that is not 0. So partial variation would follow this equation. If we look over here, 1a has y equals 4x. So we have some constant being multiplied by our independent variable, but we don't have any y-intercept, which means it's 0. So this would be an example of direct variation because it follows that equation. For our second question, we have our isolated variable. So we have our dependent variable. And then we have our mx over here, which is our constant times our independent variable. And then we have our y-intercept, which is just some constant. So that follows the form y equals mx plus b. So that would be an example of partial variation. Question 2 says to copy and complete the table of values given that y varies partially with x. So the only difference between direct and partial variation just means that direct passes through the origin, so 0, 0, whereas partial variation does not pass through the origin. So it's just 0, some non-zero number. So as you can see here, when x is equal to 0, y is equal to -5. Because of this, we know that our line does not pass through the origin, so it is an example of partial variation. And with both direct and partial variation, we need our y to increase by the same amount every time when our x increases by 1. So we can see over here when x increases by 1, our y increases by 5. So that means when our x increases by 1 over here, our y also needs to increase by 5. So 0 plus 5 gives us 5. And we can do the same thing over here. Our x is increasing by 1 again. So our y also needs to increase by 5 again. So that would be 15. And now over here, we need to figure out our x when y is equal to 40. So we could just keep increasing by 1 over and over again until we eventually hit 40. But that might take a while. So let's just come up with an equation that represents this data set. And then from there, we'll plug in y equals 40 and solve for x. So the equation for a partial variation would be y equals mx plus b. Our slope is the number we're increasing by every time on the y side. So we're increasing by 5 every time, so our slope is going to be 5. Our x and y stay as variables, and then our y-intercept is the value of y we have when x is equal to 0. So that would be -5. Now that we have our equation for this data set, we can plug in y equals 40 and then solve for x. X is a part of this term, so to isolate it, we need to get rid of this term. So to get rid of a -5, we need to add 5 to both sides. That would give us 45 is equal to 5x. And now to get rid of this multiplying by 5, we need to divide by 5 on both sides. Dividing by 5 would cancel here, and then x is equal to 45 divided by 5, which is 9. So we know our value is 9 over here. Part B says to write an equation relating y and x, and we already did that over here. So our answer would be y equals 5x minus 5. And then part C says to graph the relation. So I'm just going to draw my Cartesian plane. So that is these 4 quadrants over here. I'm going to draw my arrows to show that these axes extend infinitely in all directions. I'm going to label my x and y axes. For every increase of 1 on the x-axis, we increase by 5 on the y-axis. So I'm going to make my increments on the x-axis go up by 1 each time. And on the y-axis, I'm going to make them go up by 5 each time. And now I'm just going to plot my points over here. So we have our y-intercept at 0, -5. So down here, we have a point at 1, 0, another point at 2, 5, 3, 10, 4, 15. And now we can draw in our line. And I'm just going to extend it in both directions. And so that would be my graph. Question 3 says a car rental service charges a flat fee of $30 for renting a car plus 25 cents per kilometer driven. Part A says to identify the fixed cost and the variable cost of this partial variation. A partial variation follows the equation y equals mx plus b. So our fixed cost is going to be our y-intercept. So that's the part that doesn't change no matter what x is. And then our variable cost is going to be the part that's affected by x. So in this case, we have to pay $30 just for renting the car. It doesn't matter how far we drive, we have to pay that $30. So that's going to be our fixed cost, or B. We do have to pay 25 cents per kilometer. So that's the part that depends on how far you drive, or that depends on the independent variable. So this is going to be our M. Now part B says to determine the equation relating the total cost, C, in dollars and the number of kilometers driven, M. So our equation for a partial variation is y equals mx plus b. We know that our B is $30. Our cost is the thing that depends on how far we drive. So our cost is our dependent variable. So our cost would be our y. And our cost depends on the number of kilometers driven, M. So M is going to be our independent variable. It's going to be the thing that we plug in to see what our cost is going to be for 1 kilometer, 2 kilometers, etc. And remember, it costs 25 cents per kilometer. So if M equals 1, it's going to be 25 cents. If M equals 2, it's going to be 50 cents. So our slope is going to be 25 cents. But remember, the cost is C in dollars. That's what it says over here. So we need to make sure our slope, or M portion, is also in the same unit. So it also needs to be represented in dollars. The way it's written right now makes it seem as if we paid $25 per kilometer. So to fix that, we need to convert 25 cents to dollars. So 25 cents is equal to $0.25. So we need to make sure we make our M 0.25. So this is going to be our equation. And let me just write it bigger. Now part C says to use the equation to determine the cost of renting the car for 120 kilometers. So 120 kilometers is going to be our kilometers driven. So M is equal to 120. And our equation is C equals 0.25 M plus 30. So we just need to plug in our M equals 120 into our equation and solve for C. So that's going to be equal to 0.25 times 120, which is 30, and then plus our remaining 30. So our cost for 120 kilometers is going to be $60. Now let's move on to question 4. Question 4 says a cell phone provider offers 2 types of monthly plans. Plan A is $20 per month for unlimited calls and texts, and Plan B is $10 per month plus 15 cents per minute of calls. Part A says to write an equation relating the monthly cost C in dollars and the number of minutes of calls M. So first let's look at Plan A. So our monthly cost C is what depends on the number of minutes of calls that we make that month. So our C is going to be our dependent variable. And for Plan A, it's $20 per month for unlimited calls and texts. So what that tells us is for Plan A, C doesn't depend on M. So if C does not depend on M, C is just equal to $20 per month. It's a flat rate. If we were to graph this out, we would have C on the y-axis for our cost, and we'd have our number of minutes on the x-axis. So if we make 0 calls and we have 0 minutes of calls, our cost would be $20. If we make 1 minute of calls, 20 minutes of calls, 40 minutes, etc., our cost would still be $20. It would be a flat line. So because C does not depend on M, we just have C equals 20 for Plan A. Now let's look at Plan B. Our monthly cost C is still our dependent variable. It depends on the number of minutes of calls that we make. And for Plan B, it's $10 per month, so that's our flat rate. You have to pay it regardless, plus 15 cents per minute of calls. So 15 cents for 1 minute, 30 cents for 2 minutes, etc. So for plan B, our monthly cost C is going to be equal to 15 cents or $0.15. And we put it in dollars because we want our cost to be in dollars as well. So we want to keep our units consistent. So C is going to be equal to 15 cents per minute, so times the number of minutes, plus our flat rate, so adding our $10 that we have to pay regardless. And if we were to graph this one out, that means if we make 0 calls, we would have to pay $10. If we make 1 call, we'd have to pay our $10, but add on that 15 cents for 1 minute, so it'd be slightly higher. And if we make 2 minutes of calls, we'd have to pay our $10, but we have to add on 30 cents, so it'd be slightly higher. And you could see our line would go at a slight angle that intersects with the y-axis at 10. Part B says to compare the costs of both plans. When is plan A cheaper than plan B, and when is plan B cheaper than plan A? So if I were to draw a rough sketch of the graphs of each of these plans, plan A would look like a flat line at y equals 20, because no matter what your x value is, you pay $20 per month. For plan B, I'll do that one in orange, but you start off by paying $10 per month, but then you pay an additional 15 cents per minute. So if your minutes are here on the x-axis, for 1 minute, it's an additional 15 cents. For 2 minutes, it's another 15 cents on top of that. For 3 minutes, another 15 cents on top of that. And eventually, after a certain number of minutes, which we don't know, plan B will catch up to plan A at around that point, and they will be equal to the same cost per month. So plan B will be equal to $20 as well per month. And then after this unknown value of minutes, plan B will actually be more than plan A, so it's above the red line. So what this tells us is that before they intersect, plan A is more expensive than plan B. And after they intersect, plan B is going to be more expensive than plan A. So if we can figure out the point in which they intersect, so at how many minutes plan A is the same cost as plan B, then we'll know when plan B is cheaper, and we'll know when plan A is cheaper. So the equation for plan A is C is equal to 20. And the equation for plan B is C is equal to 0.15 m plus 10. When they intersect, they're going to have the same C value, and they're also going to have the same M value. So if we know C is equal to 20, then we know that when they intersect, this is also going to be equal to 20. So we can set these equations to equal each other. So from this, we get C is equal to 20, which is also equal to this because C is also equal to that. So this means 20 is equal to 0.15 m plus 10. So now we can solve for m. M is a part of this term, so to get it by itself, we need to get rid of this term first. So we need to subtract 10 from both sides. When we do that, we get 10 is equal to 0.15 times m. To get m by itself, we need to divide by 0.15 on both sides. When we do that, these cancel over here, and we get m is equal to 10 divided by 0.15, which is equal to 66.6. And I put this horizontal line on top to show that the 6's continue forever. So what this m means is that if we plug it into either equation, we will get the same value for c. So if we plug it into equation A, there's nowhere to put m, so c is equal to 20. And if we plug it into equation B over here, we should get c is equal to 20 as well. So going back to our graph, that means this unknown m value where they intersect is actually 66.666 minutes. So to answer our question, when is plan A cheaper than plan B? So when our m value is less than 66.666, plan A in red is more expensive than plan B in orange. And when our m is greater than 66.66 minutes, we can see that plan B is actually greater than plan A. So we can write plan A is cheaper than plan B, so plan A is less than plan B, when m is greater than 66.6. So we see that over here, when m is greater than 66.66, plan A in red is cheaper or less than plan B in orange. And the opposite is true when m is less than 66.66. So when m is less than 66.66, so on this side of the dotted line, plan B is actually cheaper than plan A. And that is it for today's video. So I hope this helped you out. If you liked it, leave it a thumbs up. Let me know what you want to see next in the comments down below, and I'll see you in the next one.